Hello everyone, my name is Yuan Li. This is my advisor, Wang Jing. I will take a moment for everyone to introduce my long paper, Graph Attention Networks with Memory Fusion for Aspect Sentiment Analysis. My next speech process is through as follows. The first one, introduction. The second, our modes. The third, evolution. The finally, concluding. First, this is the aspect sentiment classification task definition. Giving a sentence and an aspect that appears in a sentence. Aspect sentiment classification aims to determine the sentiment polarity of the aspect. In aspect sentiment analysis, various attention models are commonly used, such as this. The current attention model may inappropriately focus on syntactically unrelated context words, such as this example. When producing the sentence polarity of the price, the attention machine will focus on the word poor, which is not related to the syntax. With the rapid development of the graph neural network, graph convolutional networks have also widely used in aspect sentiment classification tasks. It offers a dependency tree to explore syntactically information and word dependency. In the example, the price is risen, although the salary is poor. This is adjacent matrix from the dependency tree, but the model assigns equal weights to the edges connect between words, so that words may mistakenly associate syntactically unrelated words to the target aspect through interactions of the graph convolutional propagation. Because of the above shortcoming, we have made a specifying improvement and proposed the model graph attention networks with memory fusion. Our model is mainly composed of the following four parts: a context encoder, a graph attention layer, a convolutional layer, and a memory fusion layer, as is shown in figure 1. The first, the graph attention layer is applied to 6 different ways to the x, so the concatenate attention. The hi and hj is through the context encoder. So the ice hidden state like this. The k is a multi-head, is a similar multi-head. So we get the final repetition HL through the graph attention layer. The second, the convolutional layer. The idea from the convolutional layer was applied to extract local n-gram information. In the window of the omega words, we can get the CI through the compute like this. So the repetition for words I is this. We can also get the final repetition of the convolutional layer HC. In order to learn aspects specifying content for memory fusion and the final classification, We use aspect-specifying masking, like this. Calculate the attention source for i's words in HA and j's words in HL. The attention source width and final repetition of graph attention layer are computed as. So we can get the final SG. Similarly, we can get a final repetition of convolutional layer SC. So the final probability distributed in class Y through the softmax like this. To compare the proposed model with other aspect level sentiment analysis model, we conduct experiments on the following 5 commonly used datasets. The statistical description of this corpus as is shown in Table 1, like this. To comprehensively evaluate the proposed model, we select the following baseline models: the convolutional neural networks, the attention neural networks model, the graph neural networks models. To evaluation metrics, we select accuracy and the macro average F1 score. Experience results. As indicate, graph attention on direction outperformed all baseline model by using FE score. In terms of accuracy, except results slightly lower than TNet LF model on restaurant 16. Both graph attention on direction and direction achieve better performance. The reason is that the proposed model can capture both syntactic and local information, that's improving performance. Ablation study results. As indicate, removing the position weight keeps the performance on laptop 14, restaurant 15, restaurant 16 to decrease. However, the performance of graph attention without position increased every source by 1.26 when used Twitter and restaurant 14. Since the local information is less important than syntactic, compare ASGCN to direction graph. The proposed graph attention on direction without convolution achieve better performance, especially in Twitter and restaurant with FE score improvement of 0.164% and 1.74%, respectively. That result shows that graph attention on direction without convolution outperforms the ASGCN model in most cases, indication that graph attention layer with different age weights are more effective than graph convolutional layer with equal age weight. Attention visualization. A deep corner indicates that more weight is assigned to the token, according to the contribution to the final classification. As indicated, ASGCN announced the statistically unrelated words to be associated with the target aspect, such as great for OS, good for Cajun shop, and totally weird for place. However, graph attention networks tend to block graph convolutional propagation from unrelated words to the target aspect by assigning attention weight to the x. The convolutional operation can also exploit some explicit structure, such as not great and not inviting. Such a phrase are expressive and text specifying. That's improvement. We investigated whether the number of layers can determine the proposed model's performance. As indicated, the best performance can be achieved when layer is 2 on Twitter, 7 on laptop 14, 3 on restaurant 14, and 6 on restaurant 15 and restaurant 16. When layer greater than 7 or decreasing 10 to both metrics in present. As layer reached 10, the model contains too many parameters and become more difficult to train. Conclusions and future work. This study presents a graph attention network with memory machine is proposed for aspect sentiment analysis, which composed of the following parts: a context encoder, a graph attention layer, a convolutional layer, and a memory machine layer. The future work. We want to improve the graph attention layer and the dynamic tuner the attention score. Thank you for listening. This is a reference.